Section 1. The building blocks of language: alphabets. Alphabets are the foundation of all written communication. Have you ever wondered how we communicate using languages? It's fascinating to think about how these symbols come together to form meaningful expressions. It all starts with simple building blocks called alphabets. These are the essential elements that allow us to convey our thoughts and ideas. An alphabet is a finite set of distinct symbols. Each symbol has its own unique sound and meaning. We use these symbols to form words and sentences. By combining them in various ways, we create the vast array of words we use every day. Think of the English alphabet. It has 26 letters from A to Z. Each letter plays a crucial role in the structure of the language. This is a finite set of symbols we use to construct English words. Without these letters, written communication would be impossible. But alphabets aren't limited to just letters. Different languages have their own unique sets of alphabets, each with its own history and evolution. For instance, computers use the binary alphabet, which only has two symbols, 0 sada and 1 u. This simple yet powerful system is the basis of all digital communication. These two symbols are the backbone of all computer operations. Amazing, right? From the simplest text message to complex software, it all starts with these basic building blocks. Section 2: Strings. Putting letters together. Now that we know about alphabets, let's talk about strings. Strings are fundamental in both language and computer science. A string is a sequence of symbols taken from an alphabet. These symbols can be letters, numbers, or even special characters. Think of it like forming words using letters. Just as we create words in English, we can create strings in programming. For example, cat is a string over the English alphabet. It's a simple yet powerful concept. Similarly, 10101 is a string over the binary alphabet. Binary strings are crucial in computing. Strings can be as short as a single symbol or as long as you can imagine. They can represent anything from a single character to entire books. Each string has properties like length, which tells us how many symbols are in it. This is an important attribute in both text processing and data storage. The string cat has length 3. This means it consists of 3 characters. We can also talk about substrings, which are smaller strings within a larger string. Substrings are useful in searching and manipulating text. For instance, at is the substring of cat. Understanding substrings helps in breaking down and analyzing larger strings. Section 3: Concatenation, combining strings. Just like we combine words to form sentences, we can combine strings using an operation called concatenation. Imagine you have the string hello and the string world. Concatenating them would give you hello world. We simply join the two strings together. Concatenation is denoted by placing the strings next to each other. This operation is very common in computer programming and helps us manipulate text efficiently. For example, when you type a web address, your computer is concatenating strings to find the correct website. Section 4: Languages, sets of strings. In this section, we will explore the fascinating world of languages and how they are constructed from sets of strings. Now let's move on to languages. Languages are fundamental to communication and computation. A language over an alphabet is a set of strings formed using symbols from that alphabet. These strings can be words, sentences, or any sequence of characters. Think of it as all the possible words you can form using a specific alphabet. Each combination of letters creates a unique string. For example, the English language is a set of all valid English words. This includes every word you can find in a dictionary and even new words that are added over time. It's an infinite language because we can keep creating new words. New terms are coined regularly, especially with technological and cultural advancements. On the other hand, the language of all possible 3-letter strings over the English alphabet is finite. There are only so many combinations you can make with 3 letters. We can have languages for different purposes. Each language serves a unique function, whether for human communication, literature, or technical instructions. For example, programming languages use specific rules to create instructions for computers. These languages are designed to be precise and unambiguous, ensuring that computers can execute tasks accurately. Section 5: Representing languages. There are different ways to represent languages. One way is to simply list all the strings in the language, but this only works for finite languages. For infinite languages, we need more sophisticated methods. Regular expressions are patterns that describe a language. They use special symbols to represent sets of strings. Another way is to use finite automata. These are abstract machines that recognize strings belonging to a language. They have states and transitions, and by processing a string, they can tell us if it belongs to the language or not. Section 6, properties of languages. Just like numbers and sets, languages also have properties. We can talk about subsets, where one language is entirely contained within another. For instance, the language of all English words starting with A is a subset of the English language. We can also talk about the union of languages, which combines all the strings from both languages. Similarly, the intersection of languages contains only the strings that are present in both languages. Understanding these properties helps us analyze and manipulate languages effectively.